And I'll say again, good morning, class, and welcome to 90 Notes. Say hi, everybody.
Hello.
Oh, yay. All right, well, today's topic of coordinate proofs, I want to point out that we've already seen this a little bit before. Remember when we learned about this? We learned about, for example, the rotation, 90 degrees about the origin. We said the rule AB maps to opposite of BA. That is a form of having variable coordinates. So let's get right to it. Let's see how our links goes. And you all know what we're going to do. We're going to say there's an L. Now L is going to clearly be in the third quadrant. There? No. There? No. Where should it be? And we all remember this from last time, that it should be on this line, y equals x. So I'm going to put L on the line y equals x. Where? I don't know. Now, you don't really have to draw that line, but you can eyeball it. It's equidistant from the perpendicular distance between the x-axis and the y-axis. Opposite, it says negative s, because we have a single variable. That variable must be the same. There can be only one value of s. Now, we also learned a while back that this is the line y equals the opposite of x, or y equals negative x. The slope of this line is 1. The slope of this line is negative 1. Those slopes are opposite reciprocals. Heavens to Murgatroyd, it just all comes together. Now, if I put L down here, where are we going to put y? Well, again, this is y says negative s. Which quadrant? Give me a quadrant. 1, 2, 3, 4. It's got to be adjacent to the third quadrant, right? Because L, Y, and X. Which quadrant? 2. I like that. Directly above it, because it's negative s in the x-axis, and it's the same distance. It's s units above the x-axis. It's kind of nice. And you see where this is going. Oh yeah, Josh says, I know where this is going. N is going to be right there. And of course, there's your links. Now, you didn't really have to draw these lines, but it's okay if you do. Then connect the segments. And again, depending on where you drew it, yeah, your figure looks like that. Is it a square? Let's find out. Now, to be fair, we haven't really even had the chapter on quadrilaterals yet, so we may not know, but let's see if, going from our previous understanding of what a square is. Now, I want to know, what is the distance? Well, actually, what is the distance from here to here, this vertical distance? How far is it from x to n? 2. Can't be 2. We don't have a number. 2 could be a coefficient, but remember, it's a variable distance. How far is it? Okay, I'll make it easier. How far is it from here to here? From negative s to s, from negative s to 0 is a distance of s. Now, let me think of another way to do it. Let's take if I was looking at the distance, the vertical distance, what is s minus negative s? What is s minus negative s? Anybody? 2s, that's correct. S minus negative s is s plus s. So we know that the distance from here to here is 2s. The distance from here to here is also 2s. Remember, in our previous exercise, we graphed our square with one of the corners at the origin. And this is a different way of doing it. So let's see how this one comes out. As a matter of fact, we could be able to find the other sides as well. 2s there, and we've got 2s there. Right, Linnell? Right. Now, do we know anything about the angles? How do we know that? I mean, we do know that, but how? Well, no, that doesn't mean they're right angles. What gives us the right angles, though? All right, how about this? What is the slope of this line, of the line containing yn? What is the slope of that line? No, this slope is defined. It's 0. This slope is undefined. But we certainly have horizontal lines. We got this is horizontal. This is horizontal. The equation of the line containing yn is y equals s. The equation of the line containing nx is x equals s. Horizontal and vertical, and we remember from section 3.5, horizontal and vertical lines are perpendicular. So that's going to give us this. So you can go ahead and put the right angle symbols in there. But now I'm curious about, I want to know two things: the perimeter of links and the area of our little links.
Yes.
Do we know the perimeter? Oh, yeah. Just add them all up. What do we got? You got 2s, 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 and 2s. What's the perimeter? 8s. And what is the area? Now, of course, these are in linear units, and area is going to be in square units. What is the area? 4s squared. Very good. Now, to help you visualize that, you all know that this area would be s times s squared. This square represents s squared, and each of these other ones does too. And I see 1, 2, 3, 4 of them. Or another way of saying it, we could say that the area is 2s in parentheses squared, or 4s squared. Let's write that down. 4s squared. Nice. So that's your, I think that's pretty good for this one. Oh, yeah. Oh, thank you. Describe it. Well, now, again, we don't know this yet, but this figure is equal. Each of the sides is 2s, so it is equilateral. And it is equiangular. Now, a polygon that's both equilateral and equiangular is called regular. And in this case, to make our classification complete, this is a regular quadrilateral. And a regular quadrilateral goes by the common name of a square. So the fact is, you do know it's a square. It's equilateral. Each side is 4s. Yes, Linnell?
What are we doing with the line equals
Oh, we already did. I think we. Oh, did we do the diagonals? Y.
is 2s.
Y. Oh no, we did that. That's 2s. Yn is each of the sides. Each of the sides is 2s. And we'll save the diagonals for chapter 4 or chapter 8. But the diagonals, as you'll see in the future, will be 2s radical 2, which is kind of cool. All right, let's go flying. Now, where are you going to put F? Which axis? Careful, F, look at F. It is going to be on the, well, you know, it's not in a quadrant, it's on the x-axis. And that means you're going to put L on the opposite side, on the positive side of the x-axis, equidistant from the origin. The origin, A units to the left, A units to the right. And Y we're going to put on the y-axis. Now you're probably guessing right away what we've got here, and then we're going to do a proof that's very similar to this. If I want to know the distance Fy, and that would be the distance from F to Y, snap. I'm going to use the distance formula. And again, you've got x1, y1, x2, y2. So if we just follow the formula, 0 minus negative a, quantity squared, plus the opposite of b, minus 0, that quantity squared. And when I simplify that, 0 minus negative a, so that'll be a squared. And negative b minus 0 is the opposite of b. I want to change that color. Better. Now I can further express negative b squared as just plain b squared, the negative side, because I can factor out the negative 1. If I factor out a negative 1, I square it, I get positive 1. So negative b squared, or negative b, that quantity squared, and again, the negative sign must be inside the parentheses. That can be simplified to b squared. And then let's shift over here. And let's have a look at the distance from here to here. From y to L, or L to y. But, you know, personally, when I choose my x1, y1, I always choose x2, y2 to the right. So I'm going to take a minus 0 and square that quantity. 0 minus negative b and square that. Look at that algebra. And look what you get. A minus 0 is a. 0 minus negative b is b. And my conclusion, what do you think this triangle is? Isosceles. Now, yeah, because we don't know anything about the third side. Oh, too dark. Let's change that up a little bit. What do you think? Right there? Yeah, how about that? No, how about a little more like that? Magenta Monday. And that's our triangle. Now the next one is actually the same thing. When we write a proof, and this was 36 out of your textbook that most of you have never seen, and we're going to plot these guys, except this time I'm going to put point P up here in the positive region of the y-axis. Then I'll put my Q over there. So where does R go? On the opposite side. Yes, on the opposite side. And again, we don't know the values for P. We don't know how much K is. But we're just going to put it up there. And that's our triangle. So given the diagram is marked, and you see in a coordinate proof, we're not going to write the two-column business. We're just going to do the algebra. We have a formula called the distance formula, and we're just going to execute it. And maybe we throw in some words. Those of you who like your English class and you like to write words, you could say, well, since this is the distance formula, then PR is equal to this. And maybe I'll make this x1, y1, x2, y2. 0 minus negative h, that quantity squared, plus k minus 0, that quantity squared. Pretty straightforward. 0 minus negative h is h. I've got h squared. K minus 0 is k. H squared plus k squared. Sweet. And then we'll examine the length of PQ. Also a segment. And now I've got h minus 0 over 0 minus k. H minus 0 is, well, h minus 0 is h. 0 minus k is negative k, but we did this before. We squared that negative k, the negative k inside the parentheses, and it will yield a k squared. Since this triangle has two sides with the same measure, we can conclude that triangle PQR is isosceles. And that's it.
Nice. Is there a campus quiz?
I don't know. That's a great idea, Josh.
Thank you.
All right.
Those are easy things. Yeah, thank you.
Okay. All right, so we'll call it good. Everybody got that?
Yep.
We good on that? All right. We'll say goodbye and say thank you for watching 90 Notes. Goodbye, everybody.
Bye.